Bandwidth and latency in computer networking. Bandwidth. Network performance is measured in two fundamental ways, bandwidth and latency. The bandwidth of a network is given by the number of bits that can be transmitted over the network in a certain period of time. For example, a network might have a bandwidth of 10 million bits per second, meaning that it is able to deliver 10 million bits every second. It is sometimes useful to think of bandwidth in terms of how long it takes to transmit each bit of data. On a 10 million bits per second network, for example, it takes 0.1 microseconds to transmit each bit. While you can talk about the bandwidth of the network as a whole, sometimes you want to be more precise, focusing, for example, on the bandwidth of a single physical link or of a logical process-to-process channel. At the physical level, bandwidth is constantly improving, with no end in sight. Intuitively, if you think of a second of time as a distance you could measure with a ruler, and bandwidth is how many bits fit in that distance, then you can think of each bit as a pulse of some width. For example, each bit on a 1 million bits per second is 1 microsecond wide, while each bit on a 2 million bits per second link is 0.5 microsecond wide, as illustrated in the figure. The more sophisticated the transmitting and receiving technology, the narrower each bit can become, and thus, the higher the bandwidth. For logical process-to-process channels, bandwidth is also influenced by other factors, including how many times the software that implements the channel has to handle and possibly transform each bit of data. Latency. The second performance metric, latency, corresponds to how long it takes a message to travel from one end of a network to the other. As with bandwidth, we could be focused on the latency of a single link or an end-to-end channel. Latency is measured strictly in terms of time. For example, a transcontinental network might have a latency of 24 milliseconds, that is, it takes a message 24 milliseconds to travel from one end of North America to the other. There are many situations in which it is more important to know how long it takes to send a message from one end of a network to the other and back, rather than the one-way latency. We call this the round-trip time of the networks. We often think of latency as having three components. First, there is the speed of light propagation delay. This delay occurs because nothing, including a bit on a wire, can travel faster than the speed of light. If you know the distance between 2 points, you can calculate the speed of light latency, although you have to be careful because light travels across different mediums at different speeds. Second, there is the amount of time it takes to transmit a unit of data. This is a function of the network bandwidth and the size of the packet in which the data is carried. Third, there may be queuing delays inside the network, since packet switches generally need to store packets for some time before forwarding them on an outbound link. Latency can be calculated by the following formula.